Subscribe to PyProTricks for Python and competitive programming and Boostup Station for technical videos. Today we are going to count the number of set bits in the binary representation of a number. It means we have to find the number of ones. So if we take example like this 171, its binary is this one 10101011. So here we have 5 ones. So we are going to print 5 in the output. So let us proceed. So we are doing for 171 and the binary is 10101011. So we will be having two methods for doing the same. The method 1 will be using the right shift operator, greater than sign. It's a bitwise operator. And method 2 will be AND bitwise operator. So first of all, let's start with the method 1. So method 1. So if we take this number 171, it's binary, and we do an AND operation with it. So what we are going to get? We will be getting 1, right? And when we do an AND operation with 1, all other values to the left will be 0. So the AND of 1 and 1 is 1 and all others is 0. So it gives you a 1, which means that we have a 1 at this place right here. Now after doing this first operation, we will be right shifting it by 1 place, which will make it this value 1010101. The rightmost 1 from here will be gone when we right shift it. I have already discussed in previous videos. Now again we do the same operation, doing an AND with 1, and again we will be getting 1 because we have 1 and 1. So AND of 1 and 1 is 1. Again we know that we have a 1 at this place. Now again we are going to do the same operation. So now when we right shift this number by 1, we will be having 101010. This 1 from here will be gone. So now we again do the AND operation, and here we have 0 and 1. So the AND of 0 and 1 is 0. So which means that we have 0 at this place. Now we again right shift it by 1 and we will be getting 10101. This 0 will be gone. So now again we do the AND operation with it. We get 1 and so on. So you can see that whenever we get 1, we have to count it, like 1, 2, 0, we are not going to count it. Then 1, 3, then it will come here 4 and then 5. So we will be having 5 number of ones. Let us try coding the first method. So we are going to create a function here, def count set bits, and we are going to receive a number in the variable num. And let us create a variable count is equal to 0, which will be saving the number of ones in the number. And we are going to use a while loop while num is greater than 0. Now if num and 1 is greater than 0, as I showed you here, we are going to do the AND operation of this number with 1, and if it is greater than 0 means it is 1, then we are going to add 1 to the variable count right here. Okay, and if this condition holds, then we are going to increment count by 1, and every time we are going to make num is equal to num right shift by 1, as we are doing right here, right shift it by 1, so that we can get to other digits on the left side of the number, the binary digits. Okay, and this is it. We go out from the while loop and return the count. So let us run it. Print count set bits, and we are going to give the number 171 and let us run. and you can see that we got the answer as 5. Let us also try some bigger number here, like this one. So the binary of this number is right here, and we are going to insert this number into another print statement and execute it. You can see we have 7 number of ones. Let us count them: 3, 4, 5, 6 and 7. You can see we have 7 number of ones. So we have successfully counted using method 1. But what is the complexity of it? So the complexity of it is log of the number. And how is it? So if we take log of, first of all I have to import it from math library, import math, and if we do math dot log of this 171, let us try this first. You can see that we have 5 and we are going to do it at 2. Now it is fine. So log base 2, right? Log of 171 base 2, we get 7 as the answer, which means we have 8 bits right here in the binary representation of 171. So we are going to take the ceiling of this entire number, and then you get the number of bits in the binary representation of a number. So here we have 8 bits, which means that it will go for 8 iterations of this while loop. And if we go for this number, the bigger number, you can see we have 14, and you can count also. If you count all these are 14 bits. So this is the complexity of it. Now we are going to optimize it a little bit so that we can decrease this complexity. So let us move to the method 2 now. So here we are going to go for method 2, and this time we are going to use only the AND bitwise operator. So the number 171 is 10101011, and if we subtract 1 from it, like -1, we get 170, and the binary of 170 is 10101010. You can also check it right here. The binary of 170, you can see 10101010. Here we have it. So now if we do the AND of both of these numbers, the number itself and 1 subtracted from it, so what we are going to get, the AND operation of 1 and 1 is 1. For all others it will be 0, like 1 0 0, this also 0, this we have 1 0 1 0 1. So this is the number we are going to get, which is equal to 170 after doing the AND operation. Now we have 170 whose binary is this, and if we subtract 1 from it, what we are going to get, 169, and the binary of 169 is, let us calculate it, this one, 10 10 1001. So let us write it, 10 10 1001, and again we do the AND operation here. We get 0 0 0 1 0 1 0 1. And what is the value of this number? Let us find this also out. 1 0 1 0 1 0 0, 2. This is the number 168. So we got this number as 168. Now again we perform the same operation. Let me mark these. So this is the first operation, this is the second operation. Now we are going for the third operation here. So 168, 1 0 1 0 1 0 and subtract 1 from it, we get 167, whose binary is, let us find out. This is the binary of 167, 10 100 and 111. So we write it here, 10 100 and 111. and we are going to perform an AND operation with these two numbers. We get 0 0 0 0 0 1 0 1. This is the number we get. And what is the value of this number? Let us check it out. So this is the number, 5 zeros. This is the number 160. So this is 160. I will make you understand after doing all of these operations. Just wait for a few minutes. Now fourth operation we are going to go for 160, the binary 101, and then we have 5 zeros, and if we subtract 1 from it, we get 159, and the binary of 159 is this one, 100, and then we have 5 ones. So we write it here, 100 and then 5 ones, and we get this number, this one. So what is the value of this number? This is 128. This number is 128. Now again we do the same operation. So this will be our fifth time, and the number we have is 128, this one, and if we subtract 1 from it, we get 127, and the binary of 127 is 0 1 1 1 1 1 1 1. Let me show you in the program also. 127 binary is this one. We have 7 ones, and here also we have 7 ones. You can check them out. 3 plus 3 6 plus 1 7, and on the left side we have unlimited number of zeros. So now again we do the AND operation of these two numbers, and we are going to get all of these zeros because we don't have two ones in one single vertical line. So this number is equal to 0, and we are going to do all of the operations until the number is greater than 0. So now if you see, we just did only 5 operations, right? Earlier in this previous approach, we have to do the same number of operations as the number of bits in the number. Like if we put the number here, you can see we had to do 8 operations, but now we are only doing 5 operations. So we have decreased the complexity of the program. And now let us quickly code it. Here I am going to write it, def count set bits fast. We are going to receive the number as we had done previously. We are going to maintain a counter and again use a while loop while the number is greater than 0. Create a mask which is equal to number minus 1, and we are going to do an AND operation between the number and the mask, right? So the AND operation between the number and the mask, as in this first case, will be 170, and then we are going to store 170 inside the same number, which will go into the next iteration like this, and finally we will be getting 0, which means that number is equal to 0. It will exit out of the loop, and every time we are running this loop, we are going to increment the count variable by 1, because every time we are counting the 1 in the binary representation of the given number. And finally, after the while loop, we are going to return the count, and let us check it. Count set bits fast, and we are going to insert the number 171, and let me print it. You can see that we have 5 as the answer. Let us also check for this number 14422. Here is the answer, 7 and 5. From the previous method also we got the same answer. And the complexity of this second method is number of set bits, right? So please subscribe to PyProTricks and Boostup Station. That's it for now.
Thank you for watching. Now it's time to discover more. Simply click on the screen to subscribe to our channel and watch another video to discover more.